we need to prove the following. So we'll start from the left hand side, but before doing that, let's try to simplify a few of the expression. So let's consider the denominator cosine A multiplied to secant A minus cosecant A. So cosine of A multiplied to secant of A minus cosecant of A. So this can be expressed as we're going to distribute cosine of A to each of the terms. We have cosine of A times secant of A minus cosine of A multiplied to cosecant of A. Now we know that secant function, that is the reciprocal of the cosine function, meaning secant of A is equals to 1 over cosine of A. So when you cross multiply, we'll get secant of A times cosine of A, that value is equals to 1. So that means cosine A times secant A, the first term will be equals to 1. Minus, now we have cosine of A times cosecant of A. So we have cosine of A multiplied to cosecant of A. The cosecant function is the reciprocal of the sine function. So we have cosecant of A divided by sine A. And this ratio, cosine over sine, this is the cotangent function. So we have 1 minus cotangent of A. And we also know that the cotangent function, that's the reciprocal of the tangent function. So in place of cotangent of A, we can replace it with the reciprocal of the tangent function. This gives us 1 minus 1 over tangent of A. If we combine them, then we're going to get tangent of A minus 1 divided by tangent of A. Then we are going to deal with sine cube A plus cosine cube A. Sine cubed A plus cosine cubed A. So this can be also expressed as sine A whole cubed plus cosine A whole cubed. Now we're going to use the identity A cubed plus B cubed, that's equals to A plus B whole multiplied to A squared minus AB plus B squared. So here A will be represented by sine A and B will be represented by cosine A. So when we use this identity, then we're going to get sine A plus cosine A whole multiplied to sine squared A minus sine A times cosine A plus cosine squared A, which is going to give us sine A plus cosine A whole multiplied to, we have sine squared A plus cosine squared A, that's a standard identity with a value of 1. Let me note down that as well. So we have sine squared A plus cosine squared A. So this is a identity with a value of 1 minus sine A times cosine A. Now that we have simplified both the denominator, so let's plug in this value into the denominator of the left hand side. So we have 1 minus sine A times cosine A whole divided by, so cosine of A times secant A minus cosecant A, that can be replaced with tangent of A minus 1 divided by tangent of A multiplied to, so here we have sine squared A minus cosine squared A. So we can use the identity A squared minus B squared, which will give us sine A plus cosine A multiplied to sine A minus cosine A whole divided by sine cube plus A plus cosine cube A. So that's sine A plus cosine A multiplied to 1 minus sine A times cosine A. So here 1 minus sine A times cosine A will get cancelled out from the numerator and the denominator, and we have sine A plus cosine A, so that will also get factored out, and this is going to leave us with, so we have tangent of A divided by tangent of A minus 1 whole multiplied to sine A minus cosine A, which will be equals to, so we'll convert the tangent to sine and cosine. So tangent of A, so that's sine A over cosine A multiplied to tangent of A, which is sine A over cosine of A minus 1 whole multiplied to sine A minus cosine A. So the simplification is going to give us, we have sine A multiplied to sine A minus cosine A whole divided by, so we have cosine of a multiplied to, so we have sine of a divided by cosine of a minus 1, which can be combined to give us sine of a minus cosine of a whole divided by cosine of a. Now clearly sine a minus cosine a will get factored out, cosine of a will also get factored out, and we are left with only sine a, which is the expression on the right hand side. Hence proof.